Evet. Sonra ben bir kameramı açayım. Şöyle. Herkese selam. Hızlıca geçen hafta değil, ondan önceki hafta konularına, ödevlerine bir bakalım. Geçen haftanın konusu arkadaşlar hatırlarsanız shift left, shift arithmetic left, shift right, shift arithmetic right'tı. Örneklerimiz vardı. 4. örneğimizde ödev olarak vermiştim. Kendiniz çözün, çözebilirseniz demiştim. Zaten 4. ödevin cevabını da paylaştım. Şöyle hızlıca alıp test edelim. Siz de görün. Diyelim ki 3000H adresinde AB değeri olsun dedik. Sorunun bizden istediği nibble'larını bulan programı yazın diyordu. İşte bunu CH'ye yazıp, yani yüksek tarafa yazıp CX'i, komple CX'i 4 bit sağa kaydırdığımız zaman A harfi CH'de kalacak şekilde oluyor. CL'ye B0 düşüyor. Sonrasında CL'yi de low kısmı da 4 birim yani bir karakter sağa kaydırırsanız CH'da A, CL'de B olur. Şöyle 4 birim kaydırmaları göstereyim. A'ya B. Bu soru bu kadar kolay. Diyelim 8. haftayı kapatalım. 9. hafta. Okay my friends, let's switch into English. Lab assignment 9. This week's topics are rotates. Rotate left, rotate through carry left, rotate right, rotate through carry right. Actually, these visualizations are pretty straightforward and self-explanatory. I'm not going to cover one by one deeply. Just going over this visualization. Here is, let me zoom a little bit. This is our register, memory, whatever the value. Let's say value. It's hard to write with mouse. Let's say this is our value, and we want to rotate left this value by using ROL, rotate left command. If we use rotate left command, the value will rotate within itself, but also the most significant bit will be put into carry, but also will be put into the least significant bit. So we are only, for example, let's say we are rotating AL. AL is 8-bit, remember, this is 8-bit, and this is 1-bit. If we rotate AL, we rotate the 8-bit, and we keep copying the most significant bit into carry flag. Please look at the below example, rotate through carry left. This is also again 8-bit. This is also again 1-bit. Sorry for notification. This is also again 8-bit. This is 1-bit. But this time 8-bit, 1-bit. This is rotating within self. Carry is only copying the most significant bit. But rotate through carry means this is carrying over 9-bit. So this is rotating 9-bit, this is rotating 8-bit. The most important difference is this. The most significant bit is copied into carry. The carry bit will be copied into the least significant bit. But here, the most significant bit copied into carry and least significant bit. The very important difference is this. Let me go over and look at the rotate right. Rotate right is also same, but rotating to right. 8-bit. Let's say we are working with AL. 1 bit. This rotate right command will rotate the 8-bit, this value within self, but also copy the most significant bit into carry flag. Rotate through carry right will rotate the 9-bit because the value is 8-bit, the carry flag is 1 bit. It will copy the most significant bit into carry flag and carry flag into least significant bit. This is the difference between rotate right and rotate through carry right. I think you understand the difference and rotate. Please be careful with shifts. Shift is only shifting left or right. Do not rotate within self. For example, if I use rotate left 8 times, let me give an example directly on example. Let's put some value into AL, like we give example. I'm going to rotate left AL 8 times. Let's see what's happening. I open the thing and looking at the AL only. We have AB in AL. Okay, this is the value. We rotate left. Let me open the carry flag. It's not important for now, but I want to show you the visualization also. Okay, this is our case. We are rotating left. The most significant bit, which is currently 1, will be copied into carry flag and also will be diving into the least significant bit. Okay. Okay, carry flag is now 1. This one is also the same with this carry flag. Be careful. 8 times 2, 3, 4, 5, 6, 7, 8. After 8 rotation, please look at the AL value. AL is turned back to its original value. Okay? So rotate is different from shift because rotates within self. Shift is just go away to left or right. So be careful. Okay, let's change this rotate through carry left and see if it's same value or not. As you can see, the value is 55. It didn't store the original value because it will use carry flag. These rotate through carry left command will rotate 9 bits. If I rotate this 9 times, let me open the AL again. If I rotate this 9 times, it will become the original value. Okay. The main difference is this. The usage is like this: rotate through carry left, register or memory. How many times this register or memory needs to rotate? Let's open the help if there is anything we didn't mention. Rotate left, rotate operand 1 left. The number of rotates is set by the operand 2. Operands can be memory immediate, register immediate, memory CL, register CL, like shift. Rotate is no different than shift in parameter operand. algorithm is shift all bit left. The bit that goes off is set to carry flag, and the same bit, the important thing is here, the same bit is inserted in the rightmost position or the least significant bit. Okay, here's a little example. The only affected flags are carry flag and overflow flag. If the overflow is 0, keeps the original sign. This is not that important. Okay. The other command, rotate through carry left. Okay, parameters are same, like shift, like rotate left. This time, rotate operand 1 left through carry flag. The number of rotates is set by operand 2, exactly the same. When immediate is greater than 1, assembler generates blah blah blah. This is not important. Machine code undefined instruction. It's saying that when you generate a code like this, it will split those values into 1, because machine code accepts only 1. It's saying that in here. The same principle works for all shift rotate instruction, but you only write this in here, rotate through carry left. Okay. Shift all bits left. The bit that goes off is set to carry flag, and previous value of carry flag is inserted to the rightmost position. The previous value, not the same value that goes off, but the previous value of carry flag. It is important. Okay, blah blah blah. It gives some example, but this time it sets the carry flag. For example, in our example, we start with a carry flag 0. That's why 9 rotation will result in the same result. But for example, if I say set carry flag and rotate 9 times, let me open the things. The least and most significant bit is already 1, so this may not affect the result. Yep, this didn't affect the result because the value AB is already the most significant and the least significant bit are 1. So it didn't affect. But it stores the carry flag in the original value. For example, now the carry flag is 1. We run the rotate 9 times. At the end of this 9 rotation, the carry flag is again 1, because the 9 rotation is completed. The previous value of carry flag is 1. So that's it. This is rotate through left. Let's open rotate right. Where is rotate right? Rotate right. Rotate operand 1 by right. The number of rotate is set by operand 2. Algorithm is shift all bit right. The bit that goes off is set to carry flag, and the same bit is inserted to the leftmost position. Exactly same. Parameters are same. Flags are same. Rotate through carry right. Exactly same. Yeah. Okay. I close this help document and go over the examples if there isn't any question. Is there any question? Sorusu olan var mı arkadaşlar? Örneklere geçmeden önce. Yok sanırım. Okay. Write a program that reads a word, it's important, a word, from 300H memory address and count the ones in this value. Then write count to dx. We are going to count the ones in this memory location. That's why at first I'm going to put some value at that memory location. Let's put AB again. And I'm going to count with rotates, because this big topic is rotates. Which rotate should I use? Which rotate should I use? Any idea? I'm going to count the number of ones in AB. Let me show the ones in AB. By the way, oops. Roll or roar? Utku says it doesn't matter. By the way, it says word, so this is a wrong usage. We need to put a word in here. It accepts, but I should use word ptr in here and use not 3000, it's 300. I'm going to use AX to rotate. I'm going to use rotate left, AX. Okay, how many times should I rotate in order to count the ones in a word? Yep, Utku is right. I should rotate 16 times because the word is 16-bit. Okay, I can rotate 16 times directly like this, but this is a single line and I need to count the ones. So I need to do this rotation within a loop. Okay. Let's create a loop by a keyword and some unconditional jumps for now. And I'm going to rotate one by one. At every rotate, when we rotate through left, I'm going over to visualization. When we rotate through left, at every rotate, I'm going to count the carry flag. How can I count the carry flag? I can look at the carry flag if it is 1 or not. Let's say I need a jump which looks to carry flag. For example, JC or J not C. JC means short jump if carry flag is set to 1. J not C means short jump if carry flag is set to 0. Pretty straightforward. I'm going to use not C. When carry flag not set it will jump. But let me. I'm going to use dx as a counter. Increase dx when carry flag is so when not set, it will going to jump döngü. Okay. But this needs to be end at some point. This is unconditional jump. How many times is 16? So I don't need an unconditional jumps. I can use CX with 16 value and use this loop keyword. Remember, runs CX times. This is our loop. This loop will run CX times. It will rotate 1. Okay, let's go over and look. FFFF, there are 16 Fs. Let's change this example into F0, F0. There are 8 F in FFFF. Okay. 4 from AH, 4 from AL. Okay, CX is 16. We are rotating 1. Let's open the care flag because we are going to look at the care flag. Care flag is set to 1. Jump, not carry. If care flag is 0, it will jump. So this is not going to jump. And dx will be increased. Okay, dx is 1. And loop starts from the beginning. Another rotate. It will. Oh. Okay. 4 times this will go like that. Because the F. After that, it will not jump, it will not jump, it will not jump. Okay, when again a carry is 1, it will jump. Okay. Look at the dx value. Dx become 8. And the loop continues, but not increasing the dx. Oops, this is wrong. Dx counts 16 times. This is wrong. Why this is wrong? Okay, it rotates. It shouldn't jump the beginning. It should miss this increase line. So let's say we have a label in here. Yep. Yeah, this will be more appropriate. Yeah, dx is 8. This whole loop should run 8 times. There shouldn't be a jump to beginning, but there may be a jump at the end. Okay. For the first one, it didn't jump. For the second one, it didn't jump. For the third one, it didn't jump. For the fourth one, it didn't jump. But the fifth one, the fifth bit is 1. It will jump, not increased. Yeah, this will be more appropriate one. Yep, I already write it, Utku. Thanks. But there is an easier way. Do you have any idea how can I write an easier counter for this value? How can I count the ones with rotate in an easier way? Any idea? We keep looking at the care flag. If it is 1, we are increasing dx. But care flag is also a number. We can add this number. Either it is 0 or 1. It's not important. Maybe, but that's also the same, Utku. But I'm completely talking about something else. I rotate 1, and I'm going to add dx I need to add carry flag into dx. Remember, we have a add with carry. I'm adding 0 into dx and also adding carry flag into dx. This will run 16 times, but the carry flag will be set at only 8 times. So dx will be 8. Okay, this will be easier because I know that carry flag can be added into addition operation by using add with carry. Okay, so the second question, second example. Write a program that rotates the word, again a word, stored at the 300H memory address to left until it will be negative and save the rotation count in CX. Okay, we have a value in here. Let's put some positive value. This is a negative one, minus 3860. How can we put positive? Let's put okay. You don't need to put 0 here. The value is, let me open here, it is positive number 2571. The bits are like this. The question wants us to rotate this word to left. Rotate this number to left until it becomes minus. I'm going to make this by directly rotating some value and see when this value will be minus. Okay, I'm going to open this value. We are looking at the here signed part of decimal 16 bit. Okay, it is 2571 5142 10,284, etc. It goes like that, and boom, it becomes negative. How many times did I rotate? 1, 2, 3, 4. 4 times rotate is enough to make AX negative. 1, 2, 3, 4. Okay. The program wants us to rotate left until it becomes negative and save the rotation count in CX. If later that there is another question. If the last value is bigger than signed value of 100 H, then write AA. If not, write BB into some memory location. So the question has two parts. We need to rotate left until it becomes negative, and when we found that the counter in CX, we need to check if the value is bigger than 100 or not. Okay, let's write this program. We don't know how many times we need to rotate, so we need a loop again. We need to check if the value is negative or not. Any idea how can we check if a value is negative or not? By using rotate. Any idea? We are going to use rotate, and we need to check if AX becomes negative or not. We open the emulator and look at the signed version of this value. oops, it keeps saying the signed version of the AX value, but we can also check if AX is negative or positive. How can we check? Utku, any idea? Salah, Esra, Efe, Berke, any idea, guys? This is a bit important. This is a bit basic, fundamental topic. How can you understand the value or memory is negative or not? A signed memory, signed value is negative or not? Sesim geliyor mu arkadaşlar? Sesim de gelmiyor galiba. Most significant bit. Yeah, the most significant bit, if a value or register is signed bit register or memory, we can look at the most significant bit. If the most significant bit is 1, it means this is negative value. Let me rotate this register again 5 times and look at the most significant bit. Okay, this is the most significant bit for AX. We are looking at the AX as a signed value. We are looking at the signed version of this AX. Okay. The most significant bit is 0, so the value is positive. I'm rotating left by 1. Okay, the most significant bit is 0, the value is positive. Rotate again, the most significant is 0, positive. Rotate again, 0, positive. Rotate again, 0, positive. Sorry, 1, negative. As you can understand from this, if a signed register's most significant bit is 1, it means that value is negative. Okay? So, we need to understand, we need to rotate this AX. At every rotation, I need to check if the most significant bit becomes 1 or not. How can I check the most significant bit? Any idea? By using rotate, not test. Jump carry. Jump carry is jump if carry flag is set. What do you mean by jump carry, Utku? Okay, jump carry to where? To beginning, to end. We don't look at JC. JC look at carry flag. Okay, it's a bit different. Okay, we have a loop, an endless loop. I don't know how to write this, so I create an endless loop. I'm going to rotate left within this endless loop 1 by 1. After rotation, I need to check if the most significant bit is 1 or not. I don't want to use test. I can use test. Remember the test command. If I test this value with, let me use bx 1, binary, I can use test with test AX BX, and after that I can look at the 0 flag. This is the previous week's topics. We learned the test. We can direct the test test is ending. Remember, this is end operation. If the result is 0, it means the most significant bit means 0. So I can jump to beginning of the loop. Let me before test, let me increase CX. I'm going to use counter as a CX. Okay, we have a value AB. I'm going to use test BX. BX is now 8000. Rotate left and check if it is negative, not negative. Jump to beginning, rotate left, increase CX, test if it is negative, not negative. Rotate left, test, rotate left. Now it is minus. And let me open the flex. Zero flex should be set. But why it is not set? Because increase CX command zero flex is not set, so the most significant bit is 1, it will not jump. So the CX is 4. We found the counter number in here. But original value is in AX. Remember, it was 0A0B, but now it is A0B0. We changed the value. That's why we need to revert those rotates and turn it back to original if it is going to use. But let's go back to question. We found the CX. Save the rotation count into CX. If the last value, we didn't turn back to original, we are checking with the last value, signed value. We are checking if 100 is greater than what? A0, B0. How can you understand if a number is greater than another number? Please remember, we are comparing two numbers by using CMP command. We are checking the AX value with what? With 100H. Because of using A value, I need to put 0 at the beginning. Okay, minus 100. What is that value in decimal? 16-bit hexadecimal. 100 is minus 24,300 blah blah. Let me write this in here. Minus 24,320. What was our last value? It was A0, B0. Okay, now the value is minus 24,400. Okay. My question, the simplest question. Which one is bigger? The line 1 or line 3? Which one is bigger? Okay, I'm expecting answers from you guys. Which one is bigger? Ibrahim says line 1. Any other answers? Okay, yeah, it's obvious. I just want to make sure that you know that minus values different from positive values. So this is bigger. So the question says that if the last value is bigger than signed value of 100, then write AA. But our value is not bigger than 100, so we are going to write BB. right? So I'm going to check. After this check operation, I'm going to use a jump. Some jumps that looks for the signed comparison, and I need a greater jump or above jump above or jump greater. Let me open the both of them. Jump above is unsigned, jump greater is signed. So I'm going to use jump greater. Jump greater. If the AX is bigger than 100, jump greater bigger. If not, this is the smaller part. This is the bigger part. The bigger part writes what it's writing. Sorry. Bigger is writing AA into 100, 1000. AA into 1000. Smaller is writing what? BB. Into 1000, but after smaller operation we need to jump, unconditional jump to do end. Okay, let's check if it is writing BB or not. It should write BB. Okay, we have a comparison. I'm going to emulate this a bit and later go over and look at the 1000H, and it writes BB. So you have to be careful about choosing jump because these numbers are signed values. In order to compare signed values, you need to use a signed jump. You can't use jump above in here, it will result in false. But we use test function. By the way, this is not the official answer on my answers list. We already know that we can use test, but I want you to use your brain and find another answer with rotate. How can you understand without using test? We don't have it. Let's say we don't have a test. Utku already write a code. It says it puts 16 in here. Whenever a care flag becomes 1, it will jump to the end. Okay, let's copy Utku's code. Paste it here. It runs a loop. Within this loop, it rotates 1 times. If the care flags become 1s, it will end the loop. Okay, this is meaningful. Let me emulate. Okay, this will run blah blah blah blah blah blah blah. Utku, please look at the AX value. AX is now A0 B0, but it should be A0 B0, right? We rotate 1. How can I say? We keep looking at the care flag, but the signed bit is within our register. Okay, if we rotate and check, we need to rotate it back because the value needs to be there. So I'm going to rotate right 1 times in order to give the 1 back into value. Okay, now we have A0, B0. Okay, Utku? Let me show this in this visualization. We are using rotate left, not rotate through carry left. We are using rotate left. The most significant bit jump into here and dive into least significant bit. We keep checking this carry flag. If the carry flag is 1, the previous value of our register is negative. So we need to turn back to its previous value. Önce kontrol etsek olmaz Utku. Çünkü rotate yok ortada. Rotate ettikten sonra geri fileye bakıyorsun ya. Yani geri alman lazım. You need to turn it back. We are rotating left. You need to rotate right 1 times into back. This is correct. Ömer says bir sonrakine gittiği için bir önceki değeri bx ise olur. Ömer is right without using rotate right. Ömer using another register. It is heavy, but it is also correct. Okay, so the last example. This is your homework. This is a good example. You need to find the answers on your own. Write a program that rotates dx, bx, ax register combination to left 4 times. 4 times means 1 character in hexadecimal. Later write results to memory address starting blah blah. Okay, let me give you the explanation. Where's my... Okay. Let's say dx, bx, and ax. These values a, b, c, d, e, f, 1, 2, 3, 4, 5, 6. Okay, generally, rotate can only rotate 8 or 16-bit values. But now I want this 12-bit. Sorry, how many bit is this? 16, 32, 46, 48. 48-bit value to rotate. Okay. After rotation, the result should be B, C, D, E, F, 1, 2, 3, 4, 5, 6, A. Okay, this A, okay, let me show you like this. This A should rotate into here. This 3 should be into BX. This E should be into DX. The final version is here. The starting is here. Okay, your homework is this. I'm stopping this session in here. Stopping this record in here. Okay.